All right, so we're going to talk about work and energy. So, energy, I have a couple definitions for you. My favorite is that energy is the stuff that makes stuff do stuff. And this applies to all types of energy. The more official definition for energy is that energy is the ability to do work. So, in the SI system, work is equal to force times distance. And so, talking about the units, then this would be newtons times meters, which is joules. In the English system, it's still work, which is force times distance. But when we're talking about force, it's pounds and distance is feet. So then we end up with foot pounds for the English system. We are basically only going to be using the SI system, so you do not need to worry about the English system units. And the law of conservation of energy, which most people have heard, is that energy cannot be created or destroyed. Um, and in reality, this is actually conservation of mass and energy together because E equals mc squared. So there is energy in the mass of something. Just because it has mass, that means it also is going to have a certain amount of energy. This is kind of like a little cartoony joke. It says, I'm not just lazing around, I'm conserving energy. And it's not something I do for fun, it's the law. So, kind of clever and funny. So, one analogy that I like to use for energy is like money. I can hand you a $20 bill and you can exchange it. You could get it $21 bills or 80 quarters or a $20 gift card or $20 in your bank account or 2,000 pennies. And all of these would still be worth $20. So you could exchange your $20 bill for $21 bills. You walk next door to Kmart and they can hand you a $20 bill again in exchange for your $1 bills. And this is kind of like how energy gets transferred between different types. For example, kinetic energy is the energy because something's moving, and you can exchange that for gravitational potential energy. And so you can go back and forth between these two without losing anything. Or you can buy stuff. So I have another example here where I can take my money and I can go to Circle K. Okay, so I go to Circle K. I have $20 to buy snacks, and I buy pies, hot dogs, a Froster, well, $3 worth of Frosters. It's not just one of them. $7 worth of chips and $1 worth of M&Ms. So I spend all $20, and then I go to Vaughn's to buy milk. Can I buy the milk? I have $20 worth of snacks, of pies, hot dogs, Frosters, chips, and M&Ms. But if I were to walk up to the cashier at Vons and go, "Here, I'll trade you. You take some of this snack food and give me this gallon of milk," they'll look at you like a crazy person. So energy is like money. You still have that value of $20 of stuff, but you can't exchange it for anything else. It's not that you've lost the $20. It's that it's like you can't just exchange it for other stuff now. And so there are forms of energy where it's like, yes, you have that energy there. That's nice, but you're not going to be able to exchange it for other stuff. I'm going to take this analogy one step farther. I also like to think of it as like an exchange rate. So here I have one of the published exchange rates that I found. Thank you, Google Images. Like if I take all my money and I put it into US dollars, and then I take all my US dollars and put it back into PKR, whatever that is, I will end up with less money than I started with. So, this is similar to real life energy because sometimes when you transfer energy from one type to another, you're going to essentially lose some of that money, but it's not gone. It's just that it's in a form that's not useful. And in the example of our exchange rates, the company that did the exchange is going to keep some of that money. The money's not gone, you just don't have it anymore. It's not useful to you. In an energy example, this could be converting chemical energy in your car into mechanical or kinetic energy. Some energy is going to be lost due to heat. So what I would like you to do next is take your hands and rub your hands together slowly. And then you're going to rub your hands together harder and faster. So push your hands together hard and then rub really fast. And then I want you to notice, what do you feel? So you should feel heat. It should get warm. But you're not going to be able to make that heat do something useful. I can't just pull out my cell phone and go, okay, or use that heat that I just generated to charge my phone. That's silly. But it is still there. Oops. Likewise, I can't take my phone to a parking lot and hold my phone above a warm car to charge my phone. Yes, there's energy there in the form of heat, but that heat is essentially useless.